Hello everyone. I'm trying a new idea for this video. What I want to do now is I want to work through the whole of a non-calculator higher GCSE paper. Now what I'm going to do is I'm going to pretend that I'm you sitting the exam, and obviously we've got 1 hour 45 minutes and we're going to try and complete the whole exam in that time or less. Now as we go I'm going to be explaining key things and what I'm doing. So let's get started. This is the Edexcel June 2013 paper, and it's a non-calculator, paper 1. So the formula page is there for us. We might need to come back to that. And question 1 is a number question. So we're given some information about a difficult multiplication, that 1793 times 185 is 331,705. And the question says write down. That means we should be able to do it without actually working it out for ourselves. The value of 1.793 times 185. If you spot the difference between this and this, the only difference is the decimal points here. And you can see it's moved 3 across. So what we need to do to our answer is write the same digits, but move the decimal point 1, 2, 3 across to get 331.705. The next one is more difficult because what you've got is a division. Now what you have to do is change this original one to division so that we can work out our answer. If you rearrange this and divide both sides by 185, you get that 331,705 divided by 185 equals 1793. So that's a fact that we know. We now compare to this division and we spot the difference, and the only difference is that this has got 100 times smaller, aka the decimal point has moved twice along in the division. Now, if you think about dividing by something smaller, your answer is going to do the opposite and get bigger. If you imagine a piece of cake, if you divide it, say, into 4 pieces, that's bigger than if you divide it into 40 pieces, for example. I won't be able to draw that out fully. Can you see each answer is bigger? And that's because the number that we're dividing by got smaller here. The answer bigger. So we compare to what we did before, and instead of moving the decimal point 2 to the left, we're going to move it 2 to the right. $79,300. So that's question 1 done. Moving on to question 2. Mr. Mason asked 240 Year 11 students what they want to do next year. Keyword 240 students. 15% of the students want to go to college. Now what I might do at this stage is be thinking we're going to have to work out 15% of 240. It's a non-calculator paper. 10% equals 24 by dividing by 10. 5% equals 12 by halving it. Add them together, you've got 15% of 36. So we already know how many students want to go to college. 36 students. 3/4 of the students want to stay at school. So we have to find 3/4 of 24. So 1/4 of 240, you divide by 4, and we are going to have to use 24 because we know, if we know our times tables, that 24 divided by 4 equals 6. If you don't know that, learn your times tables and do the opposite. Now because it's 240, our answer is 60 here, so that's 1/4. We want 3/4, so you times that by 3. So 160 times by 3, well 6 times by 3 is 18. But we've got the extra 0, remember. Now what we do is we have to figure out take away 36 and we take away 180. Or what you could do is take away this all in one go. Okay, so this all in one go is going to be 216. So we're doing 240, take 216, which leaves us with students. Right, so that's the first two parts done, question 1 and 2. Moving on to question 3. Oh, lovely, stem and leaf diagram. This should be easy marks for you, really. What I always do first is an unordered one, so that I don't miss any out of our stem and leaf diagram. The lowest number we have in the first digit is a 2 from looking at all that, and we just go up to 4, don't we? So now I go along and I cross off as I go. So 2.4 is going to be represented as 2 line 4. And you can write your key straight away. 2 line 4 equals 2.4. It doesn't matter what number you use for that. Next bit, that one's done. 2.7, 3.5, 4.4, 4.5, 4.1, 4.4, 2.8, 4.1, 3.8, 3.8 again, 4.2, 3.3, 3.0, 3.7, 3.3. Now the question is asked for an ordered one. So what we need to do is we need to do the same numbers just in order. So 2's are already in order. These 3's we need to put in order, starting with 0, 3, 3. Can you see I'm making sure I've got all of them? 5, 7, 8, 8. And for the 4's, 1, 1, 2, 4, 4, 5. Little trick you should do probably, if you've got time at the end of the paper, check you've got the same amount of numbers here as you've got here. You don't want to lose a mark there. But if you've done that correctly, you get yourself 3 marks. Moving on. Algebra. So expand 3 brackets 2 plus t. Now if you've been watching my other videos, we've got half a banana here. So we draw on our half a banana. We do 3 times 2 is 6 and 3 times t is 3t. And we've got a plus in the middle, so it's a plus. Okay, that's your answer. Next one is half a banana again. 3x times 2x, well you do 3 times 2 is 6. X times x is x squared. That's that one done. And then we do 3x times 5. 5 lots of 3x is 15x. And it's a plus in the middle. Expand and simplify. We've got our full banana now, using our banana method. So, as I told you in the other video, draw on your banana and multiply each one. So, m times m is m squared. M times 10 is 10m, and it's a plus. 3 times n is 3m, and it's a plus. 3 times 10 is 30. That's the expand bit done. Now you have to simplify. So you simplify the middle bit if you've done it in the right order. And 10m plus 3m is 13m. So that's your answer. That's simplified. Okay. Algebra done. Question 5. Write 525 as a product of its prime factors. Now, I know some of you look for an even number to divide by 2. Obviously, if it ends in 5, it's not even. So we want two numbers that multiply together to get 525. Now you know your 5 times table, it always ends in a 0 or a 5. So we know that one of these numbers is going to be 5. But we need to now know, what does it times by? So to find out what it times us by, you need to divide that number. And we're going to use the bus stop method here. So how many times does 5 go into 5? Once. How many times does 5 go into 2? 0. Carry your 2 across. How many times does 5 go into 25? 5. So that's how you get your next number. What I said before applies again. It ends in a 5. So it is in your 5 times table. Now we have to do 105 divided by 5. Now I don't need the bus stop method for this because I know that 5 times 20 is 100. And then you need an extra one lot of 5, so it's 21. Okay, hope you can see that. 21 is in the times tables you should know, so you should be happy at this stage. You should know that 3 times 7 gives you 21. Now if you can't split these up anymore without using a 1 because that's cheating, you can circle them. Okay, and as a product means multiply of prime factors. These green numbers are all primes. You have to times them all together. So you get 3 times 5 times 5 times 7, or if you really want to show off to your examiner, 3 times 5 squared times 7. Okay, moving on to the next one. Question 6. Ed has 4 cards. There's a number on each card. The mean of the numbers of the 4 cards is 10, but we don't know what one of the numbers is. We have to work out what that number is. Now, what does the mean mean? Add up, divide by how many? (12) plus 6 plus 15 plus a mystery number. Why don't we call it x? Because we should all know algebra. Equals, well, what's it now? What's it add up to? If you add them all up and divide by 4, you get 10. Okay? So big divide line to show dividing them all by 10. Now this is like an equation to solve. We know here 12 plus 6 is 18, plus 15 is 33. Okay, we times it by this 4. I'll just write the equation again so you can see what's going on. Equals 10. Can you see we need to get x on its own now? So times it by 4, 33 plus x equals 40. You might do this a slightly different way. But this is what I do with algebra because I love algebra. Take away 33 from each side and you get that x is 7. Now you might not be too confident, so you might want to check again. Add up your numbers, 18, 33, 40, divide by 4, yes you get 10. So we know we've got that one right. We've got 3 marks for definite there. Okay. Question 7. Move by a vector. Translate, move. Okay. 5 minus 2. Now I always, when I teach this, do this little diagram that says the first one tells you how far across to the right, the next one how far up. Or you might have seen x, y. So we're going 5 to the right. Pick a point. This is crucial here. Okay. Now, if I was in my actual exam, I wouldn't be able to do this trick I'm doing now. But so you can see what's going on. 1, 2, 3, 4, 5 to the right. Now this minus 2 means instead of going up, you go down. 1, 2. Done. Okay, that's your new shape. That's 2 marks. Okay, next one. Describe fully the single transformation. I mark these exam papers. The amount of people that don't listen to the word single and start writing me a list of things to do is not good. Describe the single transformation that maps shape A onto shape B. So how do we go from there to there in one move? I've already given you a bit of a clue. It's not just being moved because it's a different shape, so don't try that. It's the same shape, it's not been enlarged, and it hasn't been reflected, because if we reflect, then we're not going to get it spun around, which is what's happened. So, spun around is a term to say rotate, is a proper maths word. It's being rotated. Get 1 mark for that. Rotate. What angle has it been rotated? Well, it's been, can we do this on the screen? No. Possibly. Let's have a go. No, we can't spin it round, I'm afraid. Would have liked to do that for you. But if you imagine spinning it, it has gone half a turn around, 180 degrees. Now, does it matter which way around? No, it could have gone clockwise or anti-clockwise. Okay, so you can choose. Clockwise, same way as the clock. Now, you need one more bit of information. That's 2 marks so far. And I'll show you the trick to find the point that you spin it around. Pick a point on your shape. Pick the point that it corresponds to. So the green line corresponds to that one. That point corresponds to this point. Draw a line. This point corresponds to this point. Draw a line. Can you notice they're all crossing here? So that is the point you use. Quick little trick for you there. Around point, and the point is 0, 1 for your 3 marks. Remember that trick, it's very helpful. Okay, clearing. 8. Margaret has some goats. Goats produce an average of 21.7 litres of milk per day. I'm just trying to underline keywords. That's an average. And they're doing it for 280 days. Very wordy question here. It's quite a functional one. Margaret sells the milk in half-litre bottles. Work out an estimate for the total number of bottles that Margaret will be able to fill with milk. You must show clearly how you get your estimate. Right, some questions in the exam you need to read more than once, okay? And in the actual exam, I would definitely read this one again. So, the goats are producing an average total of 21.7 milk per day for 280 days. So if that's in 1 day, times by 280 to know about 280 days. She sells the milk in half-litre bottles. Okay, well first of all we need to know how much she's going to be selling. So we need to do 21.7 times 280, and you think, wait a minute, it's a non-calculator exam. Then you think, well, it's just an estimate. Sometimes in life you don't need an exact value. So we can estimate 21 to one significant figure as 20 to make the calculation easier. You could also calculate this to 300, but we'll just stay safe at 280, I think. Now, we're going to do 20 times that. 2 times that, you just double it. It's going to be, well, to double, you can do this, can't you? Add it up twice. 0, 16, 560. We've got this extra 0, so 5,600. Okay, so we know how many litres they've got. She sells the milk in half-litre bottles. Okay, so we want to know how many halves go into this. Now, here's a little trick for you, top tip in red. Divide by a half is the same as times by 2. Okay, because what we talked about before, when you divide by a fraction, it gets bigger. So, 5,600 times by 2. Remember, you can write it out like this. add them together to double, 2, 1, 1, 1. So she's going to be selling an estimate of what 11,200. Find out total numbers of bottles. So that's done. 3 marks. Clear ink. Question 9. Matt and Dan cycle around a cycle track. Each lap Matt cycles takes him 50 seconds. Okay, so let's use M for Matt and let's use D for Dan. When Dan cycles, it takes him 80 seconds. They start cycling at the same time. Work out how many laps they will have each cycled before they get together. Now this is effectively a lowest common multiple problem. And you might know different techniques to find the lowest common multiple. I think the easiest way, to be quite honest with you, is to write them out. Okay, 50, 100. So this is first lap, second lap, etc. 150, 200, 250. Be very careful when you write these out that you don't make a mistake, because that could cost you dearly. 400. Let's get started on Dan. What's he going to be up to? He's going to be doing 80 seconds in his first lap. 160. If you know your 8 times table, you're just adding 0 on the end, by the way. 24, 32, or 320. Look, 400. You see? So we've got the same one. So how many laps they will have each cycled? Matt is quicker, obviously, because he's done 1, 2, 3, 4, 5, 6, 7, 8 laps. Dan has done 1, 2, 3, 4, 5 laps. Job done. Okay, that's it. Clear ink. Question 10. The diagram shows a garden in the shape of a rectangle, and the lengths are in algebra for some reason. 4 plus 3x is a width, x plus 6 is a height. All measurements are in meters. The perimeter of the garden, perimeter means all the way around the edge. Now what I do straight away is I say, well, if that's the perimeter, we want to know all the way around the edge. I label the other unknown lengths. Usually correctly. 4 plus 3x. So can you see I've got that? They're just the same. Opposites are the same on a rectangle. So all around the edge gives you 32. So we need to use our algebra skill. Six plus 4 is 10, 16, 20. Our x's 1, 4, 5, 8 x's. And we add them all together. That gives us all the way around the edge, the perimeter. And we already have been told that that is 32. Now you've got an equation to solve. Take away 20. Do the same to both sides. 8x equals 12. Now, people might panic here because they think, I can't do 8 divided by 12. Well, when you do the divide by 8, instead of using divide sign, just do a little cheat and use that divide sign, which makes it into a fraction. Now you think 12 over 8 you can simplify by dividing by 4. So you get halves. That's another half. It's 1.5. Okay. That's done. Next question, question 11. Debbie drove from junction 12 to junction 13 on a motorway. And on the graph you can see we're looking at a distance from junction 12 where she started. Now if you see this star, that means it's a functional skills question where you're going to be judged on how well you explain your answer, so be very careful on these. Ian also drove from junction 12 to junction 13 on the same motorway. He drove an average speed of 66 kilometers per hour. Who had the fastest average speed? So what we need to do is we need to think, well, we already know our Ian's average speed. We need to know Debbie's average speed so we can compare. Now remember, average speed has to be in kilometers per hour. We're already in kilometers, but we're in minutes. Now think about what's going to be easiest to change into hours. Well, it's probably going to be 20 minutes. We could have used 30, but then we have to extend the line a bit. It might get a bit tricky. We'll go for 20. Okay. So, in 20 mins, Debbie has done 25 kilometers. Can you see that? But we don't want to know about minutes. We want to know about 1 hour. So how do we change from 20 minutes to 1 hour? Well, times by 3. Okay. So we times by 3 and we get 75 kilometers per hour. So in 1 hour, on average, she's done 75 kilometers. So that is the same as saying 75 kilometers per hour. Okay, so this is my working out that I'm showing here. Obviously I would do it down there, but there you go. So you could say, well, Debbie has the fastest speed. Average speed. And you could say hers is 75 and Ian's is just 66. Okay. Moving on. Question 12. On the grid, draw the graph of y equals a half x plus 5 from -2 to 4. And that's all we're given. Can you see there's a gap here? That's not a coincidence. You might have recognized this from previous questions where they draw a little table out. Okay, x and y values. But they're expecting you to figure out for yourself to draw this. So we need to go from x's -2 all the way up to 4. -2, -1, 0, 1, 2, 3, 4. And now we have to figure out the y values to plot onto our graph. So we do a half of x and then add on 5. A trick I do, because I'm used to seeing these equations, I can see this as a linear equation if you've ever seen that term. So I'm going to explain what pattern we're going to get in a minute. I start on the easy ones. So I'm going to start on 4. I'm not going to start on the negatives. A half of 3 is a bit trickier. Half of 2 is 1 plus 5 is 6. Now that gives you a clue of what this might be, but let's work it out. Half of 3 is 1.5. Add on 5, 6.5. Half of 1 is 0.5. Add on 5, 5.5. Half of 0 is 0. Add on 5, 5. Now the pattern I'm talking about is here. Can you see we're going down by a half each time? I don't even have to figure this out. I've spotted the pattern. There are the other values. Now let's plot it on our graph. I'm sorry to say, because of the situation with this setup of the page, I'm going to have to draw over our results, but hopefully you can still follow what's going on. -2x goes to 4, so -2 goes to 4. -1 goes to 4.5. 0 goes to 5. 1 goes to... Sorry, we're on... Yeah, we are on 1. 1 goes to 5.5. 2 goes to 6. 3 goes to 6.5. 4 goes to 7. If you, for any reason, did a cross like this here, you should see it's wrong, because you have to join these up into a straight line because it's linear line. Okay? So that is your answer. Obviously yours wouldn't be as messy as that because you wouldn't draw over the top of your previous working out. Oh no, I didn't think ahead of this. We've got to do a bearing, so I'm going to have to measure an angle now. But I think I'll just show you the concept of what's going on. Here's a map. The position of the ship S is marked on the map. So here's our ship there. Now, from our ship, we need to, let's read it. Point C is on the coast. We can see that. Ships must not sail closer than 500 meters to point C. Now, I'm afraid to say I'm not going to be able to do this perfectly with just a pen. So we need to think and explain what we're going to have done. 1 centimetre is 100 metres. So 500 metres in our scale is 5 centimetres. This is what you'd do in your exam. You'd get your ruler, you'd measure 5 centimetres, you would get your compass out, and you would draw a circle around like that. And that gets you every single point that's 5 centimetres away from C. So that's the first bit. The ship sails on a bearing of 0.37. You would get your compass and you would measure an angle of 37 degrees to here. Now, like I've said, this might not be perfect because I've just guessed effectively. So you'll have to give me a bit of leeway on this question. We measure 37 degrees. We draw up 37 degrees. You can see in this case they don't cross, but to be honest, I'm not sure what the real answer would be when you do it accurately. Hopefully you can see the technique now. If the line was to do that and go through, then your answer would be yes, it travels too close. If this red one was your answer, then you would say no. Okay? So I'm sorry I've had to do that this way. Question 14. Wow, what have I done? Let's get rid of that. Right. Question 14. We've got inequalities. Represent this inequality on a number line. Now when you do inequalities, we use a circle for if it's got just less than. We use a filled in circle if it's equal then as well. So, minus 2 is an empty circle, minus 3 is filled in because we can include minus 3 as well. And then we draw a line across. That's your answer for 2 marks. Now, I'm afraid to say I'm about to cheat on this question because when I teach this, I've already taught solving normal equations. And I transfer this knowledge to solve inequalities. So, my little cheat is change this to an equals, just as a cheat, and you'll see how I fix it in a minute. Hopefully you know how to solve these equal signs. We have to get the numbers on one side and the letters on the other side. We're going to add 3 onto both sides of the equation. We get 8x equals 6x plus 7. We're going to take away 6x from those sides, and we're going to get 2x equals 7. This paper likes its decimals. Now we're going to have to do divided by 2. Divided by 2. Hopefully you know that 7 divided by 2 is 3.5. So x equals 3.5. Remember, we cheated. We changed this sign here to an equals, which we weren't actually. And change every equal sign to greater than or equal to. And your final answer is just that x is greater than or equal to 3.5. Okay. Next one. Moving on to question 15. As you can see, it's another starred question. So that means that it is functional skills and you will be assessed on how well you explain your answer. Now, we've got one sheet of paper is 9 times 10 to the minus 3 exactly what, but it's going to be a decimal. Mark wants to put 500 sheets of paper into the paper tray of his printer. The paper tray is 4 centimeters deep. So let me guess, we're going to have to figure out if it's deep enough to fit in the paper. So that's one sheet of paper. We want 500 sheets, so we're going to times this by 500. Now, ignore the 10 to the minus 3 for now. Let's try and figure out 9 times 500. Well, 9 times 5 is 45, and we've got 2 extra zeros. So, we can combine those two multiplications and put 4,500 times 10 to the minus 3. Now, in standard form, the number on its own, the big number, has to be between 1 and 10, not including 10. So, we have to make these digits so that they are between 1 and 10. The way we do that is 4.5. Can you see we've put the decimal here? Now, think about what we've done. The decimal was originally here, where it should be. It's gone 1, 2, 3. So that means that we have to times this number by 1,000 to get it into the right place. Okay, and we'll bring this down as well, times 10 to the minus 3. Now, 1,000 is 10 cubed. Now, hopefully you've learned that if you've got powers and you multiply, you add the powers. That's one of your power laws you should know. So, what we've got is 10 to 3 times 10 to minus 3. So we're going to add on 3 and minus 3. 3 plus minus 3 is 0. Or basically 3 take away 3, isn't it? So, 10 to the power of 0, we should know that anything to the power of 0 equals 1. So what you're actually figuring out is 4.5 times 1, aka 4.5 centimeters. Therefore, it will not fit, will it? Because we only have 4 centimeters. It will not fit. Unfortunately, he's going to have to take some out before Mark puts it in the printer. Next one. 16. The normal price, this is a tricky one. Normal price for TV, so imagine it in the shop, a nice TV, is reduced by 30%. Okay? 30% off. The sale price is 350. Now that's already had the 30% knocked off. So you're not paying 100% of the TV's cost, the original cost. You're paying 70% of the original cost, if you're going to buy it, which is 350. Now, we want the original price, the normal price. So we want 100%. Okay, because that's what we said was the original. So what we need to do is we need to figure out what 10% is, and then times by 10 to get 100%. Can you see, to get 10% here, we're not dividing by 10. Don't make that mistake. We've got 70%. To get 10, we divide by 7. And you can see this will work out nicely, because 35 is in your 7 times table. It is 5 times 7. So your answer to 350 divided by 7 is 50. So 10% is 50. To get to 100% now, we times by 10. So 100% is £500. That's your answer. This is a reverse percentages problem. It's quite difficult. Okay, moving on. Question 17. Sumit has a pond in the shape of a prism. The pond is completely full of water, keyword. He wants to empty the pond so that he can clean it. We don't really mind why he wants to empty it, that's just a problem, trying to empty it. He uses a pump to empty the pond. The volume of water decreases at a constant rate. The level of water in the pond goes down by 20 centimetres in the first 30 minutes. Work out how much more time Sumit has to wait for the pump to empty the pond completely. This is a difficult question. Okay, so the first 20 centimetres, let's figure out what's going on here on our diagram. Imagine the cross section. It's 1.3 in centimetres, 130, and 0.5 in centimetres, 50 centimetres. Now we know about when the water's gone down by 20 centimetres. So we know about it going up to here. So that's 20. So now let's imagine again that we've got our 3D shape like we have. We want to figure out the volume of water, how much water has been lost if it's gone down 20 centimetres. This is a very challenging question, let me say that. So we need to think, well, it's 20 up. Let's just take this shape on its own. 20 up. It goes 2 meters across, and 1 meter deep, 100. So if you notice, that's an awful drawing, but it should be a cuboid. Okay. We have to get the volume of that to see how much water. So we do 20 times 100 times 200. Okay. So it's going to start with a 4. And just count the zeros. 1, 1, 2, 1, 2. Big number, 400,000. So 400,000 centimetres in the first 30 minutes. Centimetre cubed, let's get our units right. Work out how much more time Sumit has to wait for a pump to empty the pond. So what we need to do is we need to think about the rest of the pond that's still filled up after 30 minutes, which gives us quite a tricky shape to work out. Okay, so I don't want to confuse you here with this one. Let's draw it again. So our new shape that we're going to have is going to be, instead of 130 centimetres, it's now going to be take the 20 away, 30. It's going to be, that's it. I'm going to split this up into 2 so we can work out the CSA, cross-sectional area, and then we just times that by 1 metre, or 100 centimetres. So we don't want the total amount, we just want to think, well, if that's 30, this is going to be 80. This is 200 across, 200 across. We've made a triangle and a rectangle. The area of the rectangle is going to be, let's do a little diagram to show rectangle, 200 times 30, so 6, 0, 0, 0. The area of the triangle, a half times the base times the height. Half times 200 is 100, times by 80 is 8,000. So the total CSA for the water left is going to be these two added together. 14000. Now, like I said, we need to times that by 100 to get the new volume. Volume water left. is going to be times this by 100, 1, 4, 0, 0, 0, 0, 0. So that's how much left. This is how much rate per 30 minutes. What if we want to know per hour? 1 hour, we're going to just times by 2, get 800,000 centimetre cubed. And we need to know, do we want hours or minutes? I'll figure it out in a sec. I think we want a number. This is what happens in a maths exam. You don't always get it straight away. I've told you, I'm in your shoes. I'm sitting this exam effectively. So I want to think now, not 1 hour, 15 mins. I think will be more helpful. And you'll see why in a minute. 15 mins, we can half it and get 200,000. Why have I chosen that? Because I know that we can divide that by 2. How many zeros have we got? 5. Yeah. Can you see how many times that goes in? 7 times. Now, what does that represent? That represents 15 minutes. So it's 7 times 15 minutes. Well, 7 times 10 is 70. 7 times 5 is 35. Add them together. 105 minutes is your final answer. Like I said, I think that's a very difficult question. How many marks is it worth? Let's think. Must be quite a lot. Yeah, 6 marks. Okay. Very, very tricky question. Well done if you followed that. Hopefully you'd pick up some marks for your working out. Right, moving on. Question 18. Solve the simultaneous equations. Now, I'm planning on doing a video on simultaneous equations, which will help you with these, but the way I break it down is into different steps, which you'll have to look at the simultaneous equations video to understand a bit more. But basically, I call a step step X, which means that we've looked at the equation and the X's or the Y's do not have the same coefficient. They do not have the same number in front. So we need to force them to have the same number in front. So I called it step X because you multiply. And you multiply the opposites. This is a 3, so you multiply this one by 3. This is a 4, so you multiply this one by 4. The opposite way around. Times 3 times 4. To the whole equation. Top equation, let's write in green. Times by 3. 4x times 3 is 12x. 7y times 3, 21y. 1 times 3, 3. Let's do the next one in blue. 3x times 4 is 12x. 10y times 4 is 40y. 15 times 4 is 60. Now, can you see how step X has helped? Because now we've got our 12s the same. And I always say put a box around the ones that are the same. And I now say stop. Same sign. Same, take away. Opposite sign. Plus. But I will go into all this in more detail in a different video. If a number doesn't have a sign in front, say the number 7 on its own, it's not a minus, it's a plus. So we know that these were both pluses, i.e. they're the same. So you're going to be doing same sign, take away. So we take away 12x from 12x, we get nothing. They're eliminated, and this is called the elimination method. We do 21 take away 40. Well, you have to think about your number line from that and count down, and you're going to get minus 19y. Another way to do this, which I don't do in my steps, is you can swap that, because I didn't want too many steps. 3 take away 60 is minus 57. And now we think we've got minus on both sides, so we can multiply by minus 1 and make them both plus. Wow, they're horrible numbers for a non-calculated paper. Let's think about our 19 times table and see if it goes into 57. 19, 38, 57. Would you look at that? 1, 2, 3. So y has to be 3 if we divide by 19. So y is 3. We've got our y value. We need our x value now. Go back to your original equations. Pick an easy one. I think that one's easy. 4x plus 7y equals 1. It's got lower numbers in. Now, look at y. That says 7 times y. We now know that y is 3. So guess what? We're going to change that to 7 times 3. 7 times 3 is 21. So we've now got 4x plus 21 equals 1. Take away 21 from both sides of the equation. 4x equals minus 20. Divide by 4. Now 20 divided by 4 is 5. But it's minus 20, so x is minus 5. That's your answer, guys. Y equals 3. X equals minus 5. If you like checking stuff, what you can do now, take your last equation, see if it works. So 3x plus 10y equals 15. This might be something you come back to at the end of the exam if you've got time. 3 times by our x value of minus 5 is minus 15. 10 times our y value of 3 is 30. And yes, we get the answer of 15, which is what we wanted. So we know we've got that question right. We've got all 4 of those 4 marks. Question 19 now. Clearing. Write these numbers in order of size. Start with the smallest one. You really need to know your maths for this one. Okay? You need to know what we talked about before. Anything to the power of 0, doesn't matter what number it is, or even algebra. X to the power of 0 is 1. Done. You also need to know 5 to minus 1. Now what you do with this is do 1 over, write this again, but do not put the minus. 5, 1. Okay? So 1 over 5, because 5 to the power of 1 is just 5. 1/5 as a decimal, so we're continuously using the same thing. It's 0.2. So we need to put in order 0.2, 0.5, minus 5, and 1. So we're going to get minus 5 is the smallest, then 0.2, then 0.5, then 1. Moving on to question 20, which is clearing. Right, looking at question 20 then, we've got a square which has length of 4x. That means that straight away we can label an unknown length here of 4x. And we know because it's a square, all the sides are the same. If it's x across here, this must be 3x to make the total of 4x. And if we carry on reading the question, we've dealt with that information. M is the midpoint of DC. So that also tells us that this is cut in half. Hence, half of 4x is 2x, 2x. So we've got all the labels that we probably are going to need. N is the point on AD where ND equals x. Yes, that's shown in the diagram. BMN is a right angled triangle. That is shown in the diagram. Find the expression in terms of x for the area of the triangle. I think this is also quite a difficult question, and it's about getting the right method to solve it. If we think about the grey area as what's going to be left over from a big square, when we take away the other white areas, then that's probably going to be the best approach to solve it. So, total area of the square is going to be 4x times 4x, which is going to give us 16x squared. And we'll go through the triangles one by one, and find each area and then take it away from 16x squared. So the red triangle here has got length 3x and 4x. Formula for the area of a triangle is a half times base times height. Doesn't matter which one we half. We can half the 4x, so it's going to be 2x times 3x, which is going to give us 6x squared. The next triangle we'll look at is this one, which is x times 2x. The area is a half times x times 2x. Half of 2x is just x, so that area is x squared. Final triangle is going to be 4x times 2x divided by 2. So it's going to be half, if we show the formula, times 4x times 2x, which is going to give us 2x times 2x, which is 4x squared. Now, from the total area of 16x squared, we want to take away 6x squared and x squared and 4x squared. If we add these three areas together, we are going to get 11x squared. So the total area in terms of x is going to be 16x squared, take away 11x squared, which is going to give us the answer of 5x squared. Okay, done. That's the expression for the area. Okay, moving on. Let's clear the screen. 21. Table shows information about the height of 60 students. On the grid opposite, cumulative frequency graph. Draw a table to the side, scroll down, and then draw the graph, the cumulative frequency graph that's going to be our answer. Cumulative frequency means that we add up as we go along. And what we do is we plot the total amount at the end of the diagram. What I mean by that is once you're up to 150, you've had 4 people. Once you're up to 160, you've had 4 plus 5 people. Okay? So we're going to plot at 150. Remember, it starts at 140. 4 people. This is the cumulative frequency. When we get to 160, we add up. We've had 9 people. When we get to 170, we add up. We've got 9 plus 16, 25 people. When we add up to 180, we go down. We've got another 27 more. Add them up, 52 people. When we get to 190, add them up. We've got 5 more, 57 people. And when we get to 200, we've got 3 more. We've had 60 people, which is a total number of people. Cumulative means you add them all up. Okay, so let's now scroll down to our diagram where we're going to draw this information on. So the first point is when we get to 150, we've had 4 people. We can quickly identify the scale. Each little square is representing 1. So that's plotted at 4. 69 people, plotted there. 170, 25 people is plotted. Can I see this? 1, 2, 3, 4, 5. Is that right or a little bit? Sorry, it's just quite hard to see this. 1, 2, 3, 4, 5. Yeah, it's just there. 180. By the time we've got to 180, the total number of people we've got is 52. So it's jumped up quite a bit. 50, 51, 52 there. When we get to 190, we've had 57. So 55, 56, 57. When we get to 200, we've had 60. So that's our total number of people there. Once you've drawn your crosses, you've got to imagine that there's different people in all these categories and you're adding them all up. These are the only totals that we're sure of that we've plotted in green. But we know that you're starting from 0 and you're going all the way up to 60. And we have to go through these points. What you get, hopefully, is a smooth curve going through every single point that would be like an S shape. I'm going to try that again because it was slightly off, as you can see. Obviously you would do this in pencil in your exam. I'm having to do it first time perfectly. Let's say they're going through there, okay? You would have to be a little bit more accurate than that in your exam, but it's quite hard the format that I'm doing this in. And that would give you all your marks. What I've just done accidentally was erased my graph, so I had to draw it again as I scrolled down and realized that we were going to need it to find the median and the interquartile range. So, drawing it back on now, let's get on with the question. The median is the middle value. Now, if you have 60 people in total, the middle value is going to be at 30 people when you've added up all those, okay? So, you go to 30, and you go down, and your median, if you read off the scale, is going to be at 172. So that's your answer. For median, 172. Interquartile range is going to be the middle half of your data. So from the lower quarter to the upper quarter. Now, if you've got 60 people, then divide it by 4, you get 15. Okay, then halfway is 30, and 3/4 of the way through your data is at 45. Now the interquartile range is talking about the gap between these two, but in terms of the height. Okay, so we go across and read off at 15, and we're at 165. We go across, we read off from 45. The upper quartile is going to be at, if we read off the scale, 178. So we need to do this distance here, which we get by doing 178 take away 165, which is going to give us an answer of 13. Okay, so now we can erase the slide and move on to the next question. Okay, so it's going to be question 22. P and Q are two shapes, two triangular prisms that are mathematically similar. Mathematically similar means they're exactly the same shape but might be bigger or smaller. So if you imagine you're here looking at this shape, and I don't know, maybe it's Honey, I Shrunk the Kids, so you get smaller and the shape's exactly the same but it looks much bigger. But in this case, it's our actual shape that's growing or shrinking, not us. So, prism P has a triangle ABC and as its cross section. Okay, this is its cross sectional area, CSA. Prism Q has triangle DEF as its CSA, cross sectional area. AC equals 6, as we can see, and DF equals 12. So on a very basic level, we've times by 2. But the key thing here is that it's the length. And that is very important to recognize, because a common mistake would just be to times anything by 2 to change. Yeah, the cross section of a prism P is 10 centimeters squared, as we can see. The length of prism P is 15, as we can see. Work out the volume of prism Q. So we want the volume of this. Now I'm going to briefly go off task and think, well, if we've got 6 here, for example, and we make it twice as big to 12, that's fine. It's obviously times by 2 for the length. However, if we had an area here which was 6 by 6, this area is 36. Okay? Now, if we're making every length twice as big, this would be 12, and the new area would be 144, 12 times 12. So what's gone wrong? Because 36 times 2 gives you 72, which is not the answer. So, let's investigate. We times this by 2, and this times 2. So for our new area, we have to do 36 times 2 times 2. And 36 times 2 is 72, times by another 2 gives us a right answer of 144. What that means is we have to times by 2 twice, aka 2 squared. So to get from 10 to here, it's not going to be 20, I'm afraid. It's going to be 10 times 2 times 2, 40 centimeters squared. Now, we need to get the volume by timesing the CSA times the length. Now we don't know the length, but fortunately we know that this is 15, it's just a length, so this is going to go to 30. So to get our answer for the volume, we do 40 times by 30, 4 times 3 is 12, you've got 2 zeros, 1,200 centimetre cubed. Hope that makes sense, because it's a very common mistake to get this wrong by not thinking about the different areas here. Okay, that's 4 marks. Moving on to 23. Let's clear the ink. A nice algebra question. What we have to think here is to simplify, we need to do something to this bottom row first of all. So let's just think about the denominator. X squared plus 12, 2x, minus 15. We need to factorize into double brackets, x, x. So they've got to multiply to make 15 and add to make 2. Okay, minus 15, my mistake. Thought that wasn't going to end nicely. So, one's going to be plus, one's going to be minus. And the numbers that times to 15 are 3 and 5 and 1 and 15. Is to get to plus 2, do we do 3 minus 5 or 5 minus 3? Obviously, it's plus 5 minus 3. So that's the top bit, the bottom bit factorized. Let's write this out again now. 4x plus 5 over x plus 5, x minus 3. Now, what we've got is a common factor of x plus 5 on the top and the bottom. So just like with ordinary fractions, we can divide the top and bottom. In this case, it's by algebra, x plus 5. Or what you So we get 4 over x minus 3 as our final answer. Nice and simple. Okay. 24. Bill works for a computer service center. The table shows some information about the length of time, T minutes, of the phone calls that Bill had. And what's happened to this data is someone's nicely grouped it for us. From 0 to 10 minutes, he had 12 phone calls. Okay, 10 to 15, 15 phone calls, etc. This is often much more useful than just giving a whole list of different times. What we've got to do is draw a histogram to show the information. There's no extra questions, so I don't have to worry about deleting this ink once it's done. So, for a histogram, you need to remember that it's a bit like a bar chart, but instead of this height showing the frequency, it's the area that shows the frequency. So that means we need to make up the frequency by multiplying across here by the height up here. Now this is already labelled for you as frequency density, or FD. And across we call it the width of the class, okay, or the class width. So for each bar where we're considering the area, we need to know how far up to go, the frequency density, and how wide it is, the class width. How wide the class width you can just find by doing from 0 to 10, it's 10 wide, isn't it? From 10 to 15, it's 5 wide. From 15 to 20, it's 5 wide. From 25 to 30, it's 10 wide. From 30 to 45, it's 15 wide. Now you need to think about, we know the frequency of calls, f, and we want to know the frequency density. If you look at this diagram that I've done, it shows that frequency, the area, equals frequency density times by the class width. Now, if you want a formula for frequency density, you can rearrange this and do frequency divided by class width, and it gives you this here. Okay, so the formula we're going to use for this is going to be frequency divided by class width, aka this number divided by this number. 12 divided by 10 is 1.2. 5 divided by 15, you might have to do a quick bit of working out. 5 over 15, like I told you the trick, divide by 5, 1 over 3. 1/3, oh, nice and tricky, 0.33 reoccurring. Interesting. 5 over 13, that's even worse. Have I gone wrong here? 15 over 5. I thought I was a bit horrible. Okay. 15 divided by 5. In a maths exam, it's all about looking at what you're doing. Does it make sense? That didn't really make sense there, did it? So I checked again. 15 over 5, much nicer. 3. 13 over 5, still not very nice. And it's no calculator exam. Not pleasant at all. Well, to divide by 5, what you can do is you can divide by 10 and times by 2. That's a trick for you. Okay. And we are almost on the last question, so this maths is getting difficult. So 1.3 is when you divide it by 10, times it by 2, 2.6. Okay. 18 divided by 10, 1.8. 3 divided by 15. Divide by 3, top and bottom, 1 over 5, 0.2. So not very nice calculations there, but we got there eventually. All of these values are going to have to be plotted up this frequency density axis. So we need to put the scale on ourselves. The highest we need to go to is 2.6. Let's think if we went 0.5, 1, 1.5, 2, 2.5, that would work. Up to 3. Is there any nicer way to do it? 0.5. You know what? Let's go with that. Doesn't matter, we're not fully using up the whole diagram. 0.5, 1, 1.5, 2, 2.5, 3. Just make that a bit clearer. We know that's frequency density. 2.53. Okay, now we just need to draw our bars on. So from 0 to 10, literally, goes across 10, doesn't it? And we want to go up to 1.2. 1.1, 1.2. That's your first bar done. Okay. The next one goes from 10 to 15. This is why it's different to a bar chart. They're not all the same. They don't have to be the same anyway. We're going up to 3. Okay, so all the way up to 3. Is that one done? Next one, up to 2.6, and it goes across from 15 to 20. 15 to 20 up to 2.6. Done. Okay, next one, 20 to 30, a little bit wider. It goes up to 1.8. Done. Next one is 30 to 45. Not 40, 45. So it's a bit wider. It goes up to 0.2, not very high at all. On our scale that we've used, each little square represents 0.1. That is your histogram drawn. Okay, so clear the ink. Next slide. Question 25. Bit of algebra here. The expression x squared minus 8x plus 21 can be written in the form of this for all values of x. This is actually called completing the square. It's told you the form to put it in. Okay. So what we have to do is complete the square on this. Hopefully you've learnt it. If not, I'll give you a quick demo. You have to half the coefficient of x, half the number in front of x, and put it in a bracket with x. So in this case, we've got x minus 4, because half of minus 8 is minus 4. Then, in the completed square form, you've put a square there. Now, just a brief understanding of what's going on. If we did do x minus 4 squared in the banana method, timesing out, what we would get, if you work that out, is 8x squared minus 8x plus 16. So we don't want plus 16. We want plus 21. So we're going to have to do a little cheat and think, we're on 16, we want to be on 21, we have to add on 5. So that means if we compare it to this, spot the difference, A is 4, B is 5 for 3 marks. Okay, right. The minimum point of the curve is M. Write down the coordinates of M. Now the completed square form is actually very useful for this purpose, because if we look at this expression for y, what we can tell is that this red thing here is definitely going to be positive. Why is that? Because it's a number squared. A number squared is going to be positive. Okay? So if we're trying to get a small number, the best that we could do is try and make this number 0. Because if we make that 0, we get 0 squared equals 0. So what do we need to put for x to make it 0? Well, 4, because 4 take away 4 is 0. Now imagine we have made that 0, then what we're left with for y is 5. So the coordinates are 4, 5. That is your answer. Okay, we are on A star work here, so don't worry if you're finding it a little bit difficult. You might not be aiming for an A star, but all the same, it's good to attempt as much as you can. Okay, a probability question. Fisa has 10 coins in a bag, so let's draw a bag. 10 coins, 1, 2, 3, 4, 5, 6, 7, 9, 10. There are 3 £1 coins. Okay, 3 times £1. And there are 7 50p coins. 7 times 50p. Okay. Fisa takes, at random, 3 coins from a bag. Work out the probability she takes £2.50. Interesting question. What we need for this question is a tree diagram. 3 picks. Okay. The first pick of a coin, probability of her getting £1 is going to be 3 out of 10. Because there's 3 £1 coins and 10 in total. Okay. So the probability of getting a 50p is 7 in 10. Now, this is a crucial bit. On our second pick, we've already taken out either £1 or 50p. So that means we've taken one out, okay, of the bag, and we've only got 9 left. So our probability is going to be out of 9. For a £1 coin, if we've taken £1 already, there's only 2 left if we've taken one out. So it's 2 out of 9. The probability has to add to 1. So what we need is not 3, obviously. We need 7 out of 9. Because there's still our original 7 50p's left. Okay, that's our second pick if we got £1. If we got 50p, we've still got our £3 coins left, out of 9 coins that are in total in the bag still. Okay, so that means that there's only, because you've already taken 150p, there's 6 50p's left out of 9 coins. Okay. Carrying on. Probability that we get another pound coin. Well, there's only now 1 pound coin left. We've taken one and then another one. So there's 1 pound coin left and 8 coins in total. Okay, and you know that the probability has to add up to 1, so 7 over 8 for 50p. If he picked a pound coin then of 50p, there's 2 pound coins left out of 8, and there's 6 50p's left out of 8. Okay. Next one, if he'd picked 50p then a pound, 1 pound's gone, so there's only 2 left out of 8 for pounds. And 1 50p's gone, so there's 6 left out of 8 for 50p. The final case, if I can fit it on okay, he's got no pound coins picked yet, so there's still 3 left out of 8 for a pound coin. And he's got, he's picked out 2 50p's, so he's only got 5 left out of 8 for 50p. Now let's look back to the question. We're talking about picking out, use the highlighter for this, if I can. We're talking about picking out exactly £2.50. We need to find the paths that add up to £2.50. So let's go. £1, £1.50p. Yep. £1, 50p, £1. Yep. 50p, £1, £1. And any of the others down here, you don't have enough. Okay. So what we're going to do now is we're going to find the probabilities of each of these yellow paths that we talked about. The highlighted paths. You times across the rows of a tree diagram and you add down at the end. So we want £1, 3 over 10 and 2 over 9 and 7 over 8. 3 over 10 times 2 over 9 times 7 over 8. We're going to need some working out in a minute. This one, 3 over 10 times 7 over 9 times 2 over 8. Okay, and the final one is going to be 7 over 10 times 3 over 9 times 2 over 8. And then what we're going to have to do is add each of these answers. But we need some working out on the side to figure out what these fractions are. So let's work out the top of our first fraction. 3 times 2 times 7. 3 times 2 is 6. Times by 7. If you know your times tables, that is going to be 6 times 6 is 36. Put another 6 on, 42. Okay, and 10 times 9 times 8. If you know your times tables again, 9 times 8 is going to be 72. Times it by 10, 720. Okay, so this fraction here is actually 42 over 720. 42 over 720, not 420. 42 over 720. Now, notice this. It doesn't matter what order we multiply things. Can you see 3, 2, 7? 3, 2, 7, 3, 2, 7. They're all the same. So they're all going to be 42. Okay. And if you look at the bottom row, it's going to be 10, 9, 8, 10, 9, 8, 10, 9, 8. So they're all going to be over 720. So what we can actually do for our answer is 42 over 720 times by 3, because we've got 3 of them. Okay, 40 times 3 is 120. 2 times 3 is 6. So your answer is 126 over 720. Does the question want us to find it in the simplest form? It doesn't say. So we're going to save ourselves a bit of effort and leave it as a fraction because that's the correct answer. And I'm sure at this stage we've probably run out a bit of time in our exam. Okay, question 27, a vectors question. PQRS is a parallelogram. We can see labelled that they're the vectors A and B, as it explains here. PQ is A. I quite like using the board for this because that really explains what a vector is. That is the vector A. It can be anywhere, okay? Anyway, back to the job at hand. B is a vector of P to S. Again, that can be anywhere. I'm giving you a bit of a clue here. So, N is the point on SQ such that Sn to NQ, so this length to this length, is 3 to 2. So, Sn, 3, NQ, 2. So that means that if we split this up, it's got 5 parts. That's 3/5. That's 2/5. Okay? Because 3 add 2 is 5. Write down in terms of A an expression for S to Q. Right. S to Q. Well, we need to get there. We need to find a path to get there. And we can't go straight there yet because we don't know what this is. So what we have to do instead is we have to go, put that 2 back, get that out the way. We have to go this way. Can you see? Now if you go backwards along a vector, you have to do the opposite. Okay, so if you go backwards, that's minus B. So it's minus B, and then you go along A, okay. Correct way, plus A. Maybe a nice way to write this is A minus B. Doesn't matter which way around you put it. A minus B would, by the way, go this way and get you to the same place. An expression for NR in terms of A and B. So we want to go from N, which is here, and we want to get to R, which is here. Now, we have just found that S to Q is A minus B. Okay, now we want to go 2/5 of the way just to go to there. So we can write, we want to go 2/5 of A minus B. Now to finish off our journey, we've got to here, we want to go up this vector. Remember what I said about moving the vectors around? That is just B. Okay, and it probably wants it simplified because it wants it in terms of A and B. Times out your half a banana method. You get 2 over 5a minus 2 over 5b plus b. Okay, you can think of this the other way around. B, 1b, take away 2/5, leaves you 3/5 b, and you've got 2/5 a. And you want to go along both paths, so you add them. Okay, that is a vector n to r. That's your answer. Okay, is there any part C? No. 28, I think this is the last question. It's been a long journey, guys. So, the diagram shows a sketch of a graph of y equals cos x. Now, if you're on your A star work and you're learning sine and cos, I'm going to show you my little trick that I use for A level. Because you need to know the difference at GCSE as well between sine x and cos x, which is that one. They're actually the same wave, the same graph, just shifted along. And I want to help you remember which is which. I'm going to help you remember, hopefully, with a little snowboarder. So if we imagine our snowboarder here, okay, he's ready to go. Our snowboarder starts off here at the start, okay, where x equals 0. Now he wants to snowboard down a hill, preferably. He needs to think which one is cool enough to snowboard down. It's the green one, isn't it? So to help you remember, the cool one is cos. Okay? Cos is cool because you can snowboard down it. So cos is that one, okay, which we can see, yep, that's cos, we can snowboard down. Anyway, slightly off topic there. Sine's not cool, you can't snowboard down it. Cos is cool, yeah. Okay, anyway, back to the question. Write down the coordinates of a point A. Well, we should know that one cycle of sine or cos is 360 degrees. The middle is 180 degrees. So guess what? This is going to be 90 degrees, and this is going to be 270 degrees. So write down the coordinates of point A. You've gone 90 degrees across, and you've gone 0 up. Okay. Part B, on the same diagram, draw a sketch of the graph y equals 2 times cos x. Now, it's nice in your question because you sometimes get a bit of a clue. You see how this is a bit too tall? That's your clue. Okay? If we just imagine that instead of going to 1, our graph can go to 2, and it fits on perfectly. 2 times cos x means you get your answer for cos x. So these are all our answers for cos x, all around here. Then we times it by 2. So when our answer was 1, we now times it by 2. When our answer was 0, 0 times 2 is still 0. When our answer was here, minus 1, that should obviously be a minus 2. Minus 1 times 2 is minus 2. 0 times 0 is 0. 1 times 2 is 2. Okay? And you can see that every single point is going to double. So what you actually get is a graph that's stretched by a scale factor of 2 in the y direction. And that green line is y equals 2 cos x. And that completes our paper. Now, like I said, I was doing this as if I was doing an exam question, an exam paper. I don't know yet if I've got full marks. One would hope that I have got full marks, but if you notice anything in the video that you think might be a bit array, slightly wrong, just leave a message on the board and I'll be sure to tell you if you're right or not. And don't forget, you can always ask a question about anything that you want on the comments to do with the video that you maybe didn't get, or you want me to explain a bit more. It's the first time I've done a whole paper on YouTube, so I hope it's been helpful, and ultimately, I hope it helps you to achieve maths.